Welcome to The Explainer. Today, we're diving into something pretty cool, bridging the gap between one of sci-fi's biggest icons in the real-world tech it inspired. Yep, we're talking about exoskeletons, from the Hollywood fantasy straight to what's actually happening today.
So let's start with the big question, right? Could we ever really build an Iron Man suit? I mean, it's the ultimate tech dream, isn't it? A suit that gives you superhuman strength, makes you basically invincible, and lets you fly. We've all imagined it for decades, but how close are we really to making that happen?
And this really lays it out. You've got the dream, and then you've got the reality. On one hand, yeah, the Hollywood spectacle. But once you strip away all the thrusters and the laser beams, what you're left with is a real fascinating technology, powered exoskeletons. And okay, they're not for fighting aliens, but they are already changing lives in some pretty profound ways.
So, what's the holdup? Why can't we just build a real-life version of Tony Stark's masterpiece? Well, it's not like people haven't tried. The hard reality is it really boils down to three huge, and I mean massive, engineering hurdles.
Okay, hurdle number one, power. That famous arc reactor, the thing that powers the whole suit, that's pure science fiction. I mean, our best real-world batteries, even the fancy lithium-sulfur ones, just don't pack enough punch. To put it in perspective, they might give you enough juice to, hover for about 30 minutes? That's a little different from flying around for hours, right?
Then there's the material problem. It's kind of funny. Iron Man is actually not a great name for it. The suit would need something way stronger and lighter, like a titanium alloy. But here's the real kicker. Even with a super strong shell, you need something on the inside to cushion the blows. Without it, a hard landing wouldn't just dent the suit. The G-forces would be lethal. It would literally crush the person inside.
And that brings us to the third and maybe the biggest problem of all. As the astrophysicist Neil deGrasse Tyson put it, well, he points out that all that power would generate a ridiculous amount of heat. He's talking about thermal management. See, all that energy has to go somewhere, and it becomes heat. We're talking so much heat it would basically cook the person inside the suit. And this isn't just a comic book thing. NASA has worked on this for decades, creating these special liquid cooling garments for astronauts. Basically suits with tiny tubes of circulating water just to keep them from overheating.
Okay, so if the whole Iron Man thing is out, what does the real technology look like? This is where we get to shift from sci-fi to what's actually possible today. Let's meet the real-world exoskeletons. So, there are basically two main kinds. You've got your passive exoskeletons. Think of them like super advanced body braces. They don't have their own motor. They just use your own strength more efficiently to reduce strain. And then you have powered exoskeletons. These are the ones with their own power source, an active system that can actually add strength or help someone move.
And you know, it's really in the medical world where these powered suits show their most incredible promise. But like with any game-changing technology, it's not all straightforward. It also brings up some really tough ethical questions.
I mean, the upside here is just amazing. We're talking about devices that can help people with paraplegia or spinal cord injuries walk again. And it's more than just the physical movement. Think about the psychological boost. Being able to have a conversation with someone eye to eye again, that brings a sense of hope and confidence that's just priceless. But here's the other side of that coin. For starters, the cost is staggering. We're talking around 80,000 euros for a single unit. That creates a huge accessibility problem right there. But there's a deeper issue too. Does this kind of tech accidentally reinforce the idea that disability is a problem to be corrected, instead of just another part of human diversity? And could it even take money and attention away from things that help way more people, like making sure we have wheelchair ramps everywhere?
Now let's move from the clinic to the factory floor, because this tech is showing up in industry too. And while it could totally revolutionize how we work, it's not without some pretty serious risks for the workers. Okay, the promise here is pretty clear. It's all about worker safety. These suits can help prevent those awful injuries you get from lifting heavy stuff all day or doing the same motion over and over. It can stop the kind of long-term strain that just destroys careers. And for both the company and the employee, that sounds like a total win-win, right?
But, and there's always a but, this tech could also lead to exploitation. Like, will managers start expecting people to work longer hours or lift heavier loads? What if the suit learns the job and eventually makes the human worker obsolete? And what about data privacy? If the suit is reading your biosignals, where does that data go? Not to mention, most of these are designed for the average male body, which could push a lot of women out of these jobs.
And of course, it was only a matter of time before this technology got the military's attention. And this is where we get into the ultimate double-edged sword.
For the military, the appeal is obvious. Soldiers have to carry insane amounts of gear, like 60 to 70 kilos. An exoskeleton could let them carry more, march further, and just generally reduce the brutal physical wear and tear on their bodies.
But this path leads into some really dark ethical territory. You risk turning soldiers into objects, just a biological part inside a military robot. That's a direct quote, by the way. It could spark new arms races, mess with global stability. And then there's cybersecurity. Just think about it. A hacked exoskeleton could let an enemy take control of a soldier's body. That's terrifying.
And this brings us to the core ethical problem here. It's something called dual-use technology. It basically means something can be used for both good and bad. So the exact same tech that helps a person walk again can be tweaked to help a soldier carry a bigger gun. And that puts a huge responsibility on the people who create and fund this stuff to think about those possibilities right from the very beginning.
So what's the solution? How do we move forward with this in a responsible way? Well, experts have a pretty clear framework. Step 1, talk to the actual users, the patients, the workers, and involve them in the design. Step 2, think ahead about how this could be misused. And step 3, just be honest about the values you're building into the technology, like who it's designed for.
At the end of the day, all this exoskeleton tech forces us to ask a really big question about the kind of future we're building, one wearable robot at a time. The question is this: are we enhancing what it means to be human, or are we starting to replace it?